Hello and welcome. Today we're diving into something that is just genuinely fascinating. We're talking about how to turn something we all throw away, used cooking oil, into a powerful, clean burning fuel. It's a real journey from the deep fryer all the way to the fuel tank, and you're about to see it's probably not as complicated as you'd think. So let's just get right to it. The big question, right? Can you actually power a car with the same oil that just cooked a batch of French fries? Well, the answer is a huge, resounding yes, and we're about to walk through exactly how that incredible process works. Okay, so take a look at this. This diagram right here is going to be our roadmap for this whole explainer. Now, I know it looks like a lot, 16 steps in all, but don't worry, we're going to break it down together, piece by piece, into four main phases: the preparation, the reaction, the purification, and then the final polish. All right, let's jump in. So at its heart, this whole thing isn't some kind of magic trick. It's just really cool chemistry. We're literally taking that waste vegetable oil and putting it through a chemical reaction that rearranges its molecules. We're turning a thick, greasy oil into a thin, clean fuel that a diesel engine can actually use. Every great recipe starts with good prep work, right? And making biodiesel is absolutely no different. This whole first phase is just about getting our main ingredient, that used cooking oil, all cleaned up and ready for its big transformation. So this preparation phase has four key steps. First, you just have to store the oil you've collected. Pretty simple. Then you pre-filter it to get all those little leftover food crumbs and gunk out. After that, you heat it up to get it flowing nicely. And finally, you do a quick chemical check. It's called a titration, just to know exactly what you're working with. And that temperature is super important. 55 degrees Celsius, which is about 130 Fahrenheit. See, heating the oil to this point is key because it lowers its viscosity. In other words, it makes it thinner, less like syrup, so it can mix properly in the next stage. Now, that word titration, it might sound a little intimidating, but it's really just a simple test. Think of it like checking a recipe. Because not all used oil is created equal, this quick check tells you the exact amount of your reactive ingredient you need to add to get that chemical reaction just right. And here we go. Now we've arrived at the very heart of the process. This is the reaction. This is where the real transformation happens, turning that prepped oil into raw, unwashed biodiesel. This is the fun part. So, to kick this whole thing off, we need something called a catalyst. In our case, it's a mix of potassium hydroxide, or KOH, and methanol. This mixture, which is called methoxide, is basically the spark that starts the fire. It breaks apart the fat molecules in the oil and rearranges them into something brand new. Once that methoxide is poured into the warm oil, it is time to mix. And listen, this isn't just a quick stir with a spoon. This mixture needs to be agitated for a minimum of 2 hours. That's what makes sure every single molecule of oil gets to meet the catalyst and has a chance to convert into biodiesel. After all that mixing, all that action, the machine is turned off for what is one of the most critical and patient steps in the whole process. You just wait. For at least 4 hours, the mixture is left totally still, so gravity can work its magic and separate everything inside. And this is what happens while you're waiting. The reaction actually creates two different things: our much lighter biodiesel and this heavy, dark byproduct called glycerol. And because the glycerol is way denser, it just naturally sinks to the bottom, creating this perfect separation line you can see right there. So getting rid of that byproduct is actually incredibly simple. You just open a valve at the bottom of the tank, and all that dark glycerol just drains right out. What you're left with is called unwashed biodiesel. So we're getting really close, but it's not quite ready for an engine yet. So right now, our raw biodiesel kind of needs a bath. This whole next phase is about purification. We have to wash out any leftover catalyst or soaps that got created during the reaction just to make sure the final product is incredibly pure. The process itself is really straightforward. We wash the biodiesel with water, and the water absorbs all the impurities. Then, just like before, we let it sit and separate. The dirty water sinks, we drain it off, and then we gently heat the fuel to get rid of any last little bit of moisture. Yep, after washing, we have to wait again. This time, it's for at least 1 hour. This just gives the water, which is now carrying all those impurities, enough time to fully settle out from the clean biodiesel floating right on top. Now, this final step in the phase is absolutely crucial. Water is the #1 enemy of a diesel engine. So the washed biodiesel is heated one last time to boil off and evaporate any tiny, microscopic water droplets that might be left behind. This makes sure our fuel is perfectly dry. Okay, we're on the home stretch. We have clean, dry fuel, but before it can go anywhere near a vehicle, it needs one last polish. Think of this as the final quality control stage to make sure it meets the absolute highest standards of purity. So this involves a two-stage filtering process. First, it goes through a fuel water separator, just in case any moisture's still hanging around. Then it's pushed through an extremely fine particle filter before it finally gets moved to a clean storage tank. And when I say fine, I really mean it. The final filter is rated to 5 microns. Now, to give you some perspective, a single human hair is about 70 microns thick. This filter is catching particles more than 10 times smaller than that. That is absolutely vital for protecting a modern fuel injection system. And there you have it. Just like that, the journey is complete. We have followed the entire path, from a barrel of old cooking oil, through all the filtering, reacting, washing, and polishing, all the way to a tank of clean, pure biodiesel that's ready to go. A true trash-to-treasure story. A process like this is such a powerful example of innovation. It really gets you thinking. If we can turn old French fry oil into fuel, what other everyday waste products are just out there, waiting for the right person and the right process to unlock their hidden potential?